Hello, this is chapter 17, and this time we are interfacing microcontroller with the stepper motor. This is the important part of for the electronics computer and the software engineering. The interfacing is the main part, and we must have to learn how the microcontroller can interface with the external devices. So this is the third step. In the first, we interface with the keyboard, and in the second, we interface with the LCD display, and this is the third example. So please try to understand very clearly. So this time is the stepper motor. Remember, the stepper motor is a motor. It has differences between the other conventional motors. So we will try to explain here on the basic level at least each and everything. So probably after the completion of this lecture, probably you will be able to have a clear understanding, a better understanding than before about the microcontroller interfacing with the stepper motor. So let's start. What is this stepper motor and where it is used? Stepper motors are generally used in the industry, in the automation, in the robotic arm, in the micro, in the printers, where we need a very high accuracy in the positioning. For example, so I have shown here one example, and this is I took from the YouTube channel. So this is the example of an robotic arm where the robotic arm needs to pick a one box with high accuracy, with high precision. So these are the examples where the stepper motor has high applications. So what is the stepper motor? In the industrial and the commonly commercially available stepper motor looks like this one. It has inside a stator and the rotor. The rotor is connected with this shaft. So we connect our load with this shaft, and whenever we energize using these cables, these stepper motors, then it will start to rotate. It can rotate clockwise. It can also rotate anti-clockwise direction. Let's see something more inside of this stepper motor. So here, this is the inside of this stepper motor. We can see here it's a body. Is this one is the body of the stepper motor. It is stationary. It is stationary. So it's not movable. It never rotates. It never turns. And on this stationary part, the four windings are installed, the one, two, three, four. So these are basically the four stator windings. These windings are installed on the stator, so it is the stator winding. So it it never rotate. Please remember this one. It is inside the body, so it cannot rotate. Now, in this gap, if we place a rotor, this rotor is a permanent magnet rotor, and we can see this is basically the rotor. So, and this is, of course, this is the stator as we explained before. So we can see clearly the stator of the stepper motor has windings that is stationary. That's not going to rotate, but inside this there is a permanent magnet which rotates. How it will rotate? According to the energizations of the coil. So if so we will see it clearly how it energizes. But this picture is basically the commercial version. But because in this lecture we have to understand how a stepper motor can be operated by a microcontroller, so we will use the very basic example. Okay, so now how stepper motor works, we have seen something, but we have to tell something similar to other motor. A stepper motor also has rotor and stator, as we have seen in the last slide. Stepper motor rotates in steps unlike other motors. Okay, other motors rotate continuously. For example, the servo motor or the induction motor or any other DC motor, it rotates continuously because a continuous power source is provided to them. But it is because that stepper motor are powered in the shape of the pulses. It is not powered in a continuous manner. But now we're just talking for the basic versions. So it is because that stepper motor are powered in the shape of pulses. The number of pulse determines the number of step rotation. That's right. For example, a 45-degree stepper motor will complete one cycle by 8 pulses. Okay, and similarly, an 1.8-degree stepper motor complete one cycle by applying 200 pulses. Stepper motor works without feedback. This is the main advantage. So it works without feedback. It means its controlling is is very simple. Okay, it is an open loop controller. It is used where high accuracy in positioning is required. As I shown before, it's the high accuracy is required in the robotic arm and in the automations. So these are the application of this stepper motor. Now move next. The rotor consists of permanent magnets, yes, and the stator of electromagnetic coils. What would I say? The rotor consists of permanent magnets and the stator of electromagnetic coils. Okay, the okay, yes, that's right. The design of the most simple stepper motor may looks like as I shown before the commercial version or the industrial version, but now because we have to understand from the very beginning, so I will just take a simple and the basic example. So this is the simple example of so as now we can see these are the four windings. So these are the stator. These are mounted on the body of the stepper motor, and this is the rotor. So rotor has red sign means it has north pole, and this the blue sign means it's south pole. So it's because it's a permanent magnet, it will always have north pole and the south pole. So it depends where it moves this side or it moves this side depending on the energizations of one of the coil. Out of the four coil, one coil if energized in such a way that this becomes this. If for example this coil is energized and okay, okay, if this coil is energized, it means mhm. So if this coil is okay, before this I want to explain the north and south pole. So this is the rotor, and rotor permanent magnet. It's a rotor and it's a permanent magnet. So it's this part only moves. Okay, and then the stator coil. So this is the stator coil, this is the stator coil, and again, so this I have shown the basic version of the stepper motor so that we can understand its working principle clearly and easily. Okay, it has 90-degree rotation step. What is mean 90 degree? If this one is energized, then this coil will move from north from this side to this one. So how many angle from this position to this position is a 90 degree. So then next 90 degree, next 90 degree, next. So after 490 degree, it will reach to its initial position. So it has 90-degree rotation step. The rotation is kept continue by applying pulses in a cyclic order one by one. Okay. So what is the cyclic order? What is one by one? Each of these terminology we will try to understand very clearly. Now let's suppose what's the addition here? The motor direction is controlled by reversing the order of the coil energized. Okay. How the motor direction can be achieved. the motor direction can be clockwise direction, motor direction can be anti-clockwise direction. So we try to animate this one. If this is energized first, we have 4 stator coil, and let's suppose if this one is energized first, then what will happen? Then if we energize this one, so this pole will become south pole and this one north pole. So what will happen after energization of this coil? See, south pole and this south pole will repel each other, and this north pole and the south pole will attract each other. So after energization of this coil, the rotor will rotate. Let's see how it rotates. So rotor will rotate from this position, from vertical position to the horizontal position, and it will align the rotor. The rotor north pole will be aligned with the stator south pole, and it will remain firm in these positions. Okay, so this is what types of motion is this one? We rotate it from here to here. It's a clockwise. So it's a rotation is from here to here, and we can say it's a clockwise rotation. Okay. Now, what happens if we want to get the anti-clockwise rotation? Let's see another example. If this is the motor without having power on the stator coil. So if this coil is energized first, so what will happen? It will create its own north and south pole. Let's energize this one. So if we energize this one, then this part, this becomes south pole and this become north pole, and we can see, because this south and this south will repel each other, and this south and this north will align each other forcefully. So after energization of this one, so the rotor will move. Now what is the direction of the rotor? The direction of the rotor is anti-clockwise, is from here to here. So the direction of a motor is anti-clockwise. So, or it's the direction of the motor is counterclockwise. So we have seen the motor rotor can be rotated in the clockwise direction as well as in the anti-clockwise direction. How? By just changing the order of the coil energization. Initially, we energize this one, okay, and now we energize this one. So these are the basic and the simple operation of this stepper motor. The stepper motor direction can be achieved by changing the order of the energization, as we will see furthermore in detail. So these are so far what we are covering. We are covering the principle of working, but we should know how we can change the direction so that we can design our code, we can write our code in the assembly so that we can interface the microcontroller with the stepper motor. Okay, let's say type 1 is a one phase drive. So it's an interface of the microcontroller with the stepper motor, and this is the type 1 where one phase is drive. It means only one phase is energized, or only one phase is provided to the stepper motor. What does it mean? Or that means only one coil is energized at one time. You will see this is not commonly used. Yes, it is not commonly used. It consumes less power and capable to handle only low load. Yes, because only one coil is energized, so it consumes less power, and of course, the less power, it gives less load capacity. Because of 90-degree rotation per pulse, it can make one cycle rotation in 4 pulses. That's right. So this is the example, and we can see here the animation. So let's start from here. Okay, this is energized, this coil is energized, now this and so we can see at one time one coil is energized, but in a sequential manner, in a in one pattern. Okay, 1 2 3 4, 1 2 3, 4. So this is the energization. And so what we can see here, by having one phase, or by energizing only one coil, we can get the rotation of the stepper motor. Let's do it something more. So we can write this coil as D0 coil, this coil as D1, D2, and the D3. So we name all these coils from D0 to D3. So there are 4 coils, and D0, D1, D2, D3, these are the bits we are getting from the microcontroller. So it's, yes, it is the output port of the microcontroller. So what does it mean? In order to energize this one, D0 needs to be 1. So in this case, if D0 is energized, okay, D0 is energized, and then next D1 is energized. So we can see here it's a cyclic pattern. So first the D0 is energized, and second the D1 is energized, and third D2 is energized, and fourth is D3 energized, and then it repeats itself. Again D0 will energize, and D1, D2. So this is the cyclic pattern of of the code coming from the microcontroller. So we should also remember, for one phase drive, what kind of data we can send we can receive from the microcontroller. Is the first is the decimal 1, second is the decimal 2 value, and third is the decimal 4, decimal 8, and then it will repeat 1, 2, 4, 8. So the sequence here is, we have to generate these signals from the microcontroller to the stepper motor, and this signal will have the decimal values of 1248. Again 1248, 1248. Please remember these values, as we will use these values in the programming assembly language later on. I hope you understand something. Now let me explain it uh, more clearly, step by step, bit by bit. So if this is your bit, so one value means D0 is 1, and if we make D0 is 1, so it means we are energizing this coil only. The rest of the coil is de-energized. Okay. If we apply 2 value, 2 means D1 is only has power, so D1 will power the next coil. Okay, so the next coil is energized. And now if the D2 is energized, so D2 is energizing the next uh, the next coil, and D3 is energizing this coil, and then after this one it will continue to energize one. So it will again energize this one, and two, three. So this pattern, I hope, yeah, I hope it's now very clear to all of you how it works. So we ended with this slide once again, that these will have this pattern. So remember, these are the type 1 control, or the one phase drive. It's also known as wave drive, or also known as single coil excitation. Okay, these are the same name. The bottom line is, where only one coil at one time is energized, we should follow this pattern: 1 2 4 8, 1 2 4 8. Okay. Now type 1, one phase drive. This is uh, this is example 17-3A from the book. Rotate the stepper motor continuously clockwise using the wave drive. Wave drive means one phase drive. So we will energize one coil at one time. Use the sequence values saved in program ROM locations. Okay. Uh, of course, we know that the microcontroller is cannot be directly connected with the stepper motor. Remember, stepper motor is dealing with the high voltage and the higher current, but the microcontroller cannot be directly interfaced with the stepper motor. So uh, we must need something in between so that we can get a successful interface. So these are also the part of the microcontroller interface with the stepper motor. So what is this one? This is the output port from the microcontroller. We used only P1.0 to P1.3, and this is basically opto-isolator. Isolation from IT51 is via opto-isolator because this is going to derive the higher power. So we must need an isolator so that high power signals cannot come back to the microcontroller, and it will destroy the microcontroller very easily. So in order to keep this voltage level, this current level isolated from this voltage and the current level, we must need an isolator. This is always the case, please remember. So isolation from IT51 is via opto isolators, and the IC number is shown here. And then after that, we need a power amplifier. So ULN2803 is a power amplifier. ULN2803 IC is high power motor driver. Okay, so we can drive we can drive the signal from this one from through the opto-isolator. We can get the signals from microcontroller to the power amplifier, and this probably it can be here it can be some MOSFET or some IGBT, some power transistor. So it will drive the stepper motor. So the important thing is that we are getting four signals from the microcontrollers, and these four signals are leading to drive the microcontroller, sorry, drive the stepper motor. You can see here. So please remember, microcontroller can never be directly interfaced with the unit with the stepper motor. It always use two kind of devices. The first is the opto-isolator in order to isolate the high voltage and the low voltage, and then the power amplifier. Hope you understand this one. This is the program. We should learn this program we will explain it step by step as we have seen. But what the important thing is that we loaded the RO is a counter, because we have to load first value 1, then second value 2, third value 4, fourth value 8. So we need a counter which will count up to 4 times, and then data pointer is pointing towards this database defined byte. So and then we are loading, we make accumulator clear, then we load data pointer is at 100 value, so 100 plus 0, it will move to the accumulator. So accumulator will have value 100, location value, that is 1, and then accumulator value will be moved to the port 1. And then we have this delay data pointer increment, so that it will next time it will access the 2 value. Then again, after having 2 loops, it will next time it will data pointer will increment it will access the next value, higher value 4, and then data pointer will also be incremented, and it will access the ith value, the higher, and then the process will continue to run. So this is the basic. I'm not going to explain this because I assume that we already have learned more complex code than this code before. So I'm not going to explain, but what is the important in this code? We are repeating the code, and we are loading first the value 1, the second value 2. So the motor will start to run. Okay, as we see. Okay, we also want to explain this slide next. Okay, type 1 one phase driving. Okay, so what is this? This is the program, and this is the stepper motor without energization of any of the coil. So this is without power. Figure 0 is having no power on the its electromagnetic coil. Let's suppose the program runs and value 1 is loaded to the pointer to the port 1. Okay, what will happen? So value 1 is loaded, it means this data decimal 1, it means d0 will become 1. What will happen under this condition? D0 will become 1, so this coil will energize. Okay, now the next is 2 will be loaded by the microcontroller, and it means the decimal 2 is loaded, it means D1 will energize, and we can see in the figure this time previously D0 was energized, now D1 is energized. Okay, and the direction of the motor will be clockwise. Similarly, the microcontroller will load the next higher value, that is 4. So 4 in decimal means D2 value. So where is D2 value? So D2 value will be energized and the rotor will move again the clockwise direction. So similarly, you can see the next is it. So it means D3 is energized, and D3 means this one will energize and the motor will move from this one to this one. And the cycle will continue. So again, if load value 1, of course, after loading it, the next value will be 1248, 1248. The cycle will continue, and again the motor, the shaft will reach to its initial position, and the things will continue. Hope you understand this one. Now, now we take type 2, two-phase drive. As its name implies, it is the case where two coil will energize. Okay, so we can see here the coil. This is the rotor, and these are the stator. The coil at this in figure 1, two coil is energized, A and B. In figure 2, B and A. In figure 3, A and B, but all in the sequence. A B B A B, and then B A, then A B, and then B A. So two phase drive means that means two coil is energized each time. Double phase method is widely used. Yes, double phase, I mean we are applying two phase, we are energizing this one, we are also energizing this one at the same time. So it's widely used. Yes, it consumes more power. Yes, because it is it in this case two coil is energized at one time, so of course it will take more power than in the case where only one coil was energized. So and of course if it is drawing more power, so it is capable to handle higher load. That's general. It's logical. The rotation is achieved by following a bit pattern in sequence. Okay, so 1248 was the rotation pattern in the one phase drive. Now we have to see what will be the rotation pattern for the two phase drive, because we have to generate, we have to write a code for from the microcontroller. We have to write the code on the microcontroller so that microcontroller can output these pattern to the stepper motor. Again, we have this one because in this case, for example, the figure 1, these two coils are energized, so we will energize D0 and D1. So first pattern is in decimal, it's 03. And next, because we have to energize B and A, so B and A, so again the two coils are energized, and in this case it is achieved by decimal 06 value. And again next to this one and this one, so it is decimal OC. And then this one and this one will energize, so 9 1 and 9 is 9. So again here we can say at the same time, at one time, two coils are energized. Number one is this coil and is the last coil. So what we get here, the the pattern of the signals is 03, 06, 0C and 09, and it will continue to repeat. So it will again, we will after 09 we will have 03, 06, 09. So this will to continue to rotate. This will continue to generate the signals from the microcontroller, and it will in result continuously move the stepper motor in the clockwise direction. Okay, what how we can achieve these different patterns? So we have to understand this one. If you see this one, we what we are doing, we are rotating left. I mean, one is rotated left here, one, and then one again rotated left, and then so how we have to so this is basically this pattern. If we load 03 value, and only we need to load 03 value, then what we need to do, we have to rotate left. So the sequence pattern we can achieve by rotating left. So we can see this is rotated left, in the second rotated left, left and left. So if it is clockwise rotation, so we can say if we rotate these data in the if we rotate these data left, so we can achieve clockwise direction of the motion. Now let's see how we can achieve the anti-clockwise direction of motion. Of course, we need to change the order of the of this data. So for clockwise rotation, we need to load value 03, 06, 0C, 09. Okay, let's assume, let's take this one. First we loaded 03 value, okay, in this case, but now we are moving, we are not rotating data to the left, but we are rotating data to the right. Okay, so this data is moved to the right, this data is moved to the right again, so we can see right. So so what the pattern is 03, 09, 0C, 06, and again 03, 09, 06. Okay, and we can see here the rotation of the bits are in the right direction. We can see in the right direction. Okay, so this rotate right sequence bit pattern. So if rotate left sequence pattern causing a clockwise rotation, then rotate right sequence pattern will make the rotation in the anti-clockwise direction. Hope you understand. Okay, one more example. Type 2 is this time the example of a type 2. So please remember this pattern. Okay, one more thing. The it can be started at any point. It's not necessary. We don't know where is this where is the rotor. Okay, we can start at any point. We can start from 03 value. We can also start from 06 value or 0C value 09. Any of the we can start with any of the bit pattern, either 03, either 06 can start. But in the next example where we are going now, we started by loading the value 06. Probably it is easier because we have 211 in the center, so 06. But because remember this 6 is loaded on the first half byte of the port 1, or the accumulator, we instead of 06 we can also load it 66. So the pattern will always remain same, but we will save the bit value inside the accumulator. So it can possible, instead of 06 we can load accumulator with 66 value. It will generate again the same pattern. So here we already have explained this one, but this type is a two-phase drive. A switch is connected to P2.7. Write a code to monitor the status of switch and perform following task. Number one, if switch is equal to 0, the stepper motor should move clockwise. If switch is equal to 1, the stepper motor should move counterclockwise. Okay, and the program is this one. We understand this program. So this block is the main program, and it facilitates the turning option, and this is the clockwise block. If we run this code, then the rotation will be clockwise because it rotates the accumulator value left. So rotate left function is used here. So we suppose that rotate left function causes the rotation in the clockwise direction. And the next, okay, we will try to understand step by step. So this is the monitoring bit, because we are said that if switch 0, then the stepper motor should move clockwise. Let's suppose if P2.7 is 0, what will happen if P2.7 is 0? So jump if not bit, or jump if 0. So it will jump to clockwise direction, because the 2.7 is 0. So this will jump to clockwise. Where is clock? So this will jump, the code will not run the next instruction, but it will jump to the clockwise, and then it will run this code to rotate left rotation will cause the rotation of the motor in the clockwise direction. Now assume if 2.7 is 1, so 2.7 is 1, if switch 1, this stepper motor moves counterclockwise direction. So switch 1, then it should not move to the clockwise direction. If switch 2.7 is 1, it means jump if 0. So this is not 0, this is 1. It will not jump. Instead, it will go to the next instruction. So next instruction is providing rotate right function. So if we perform rotate right function, then we will definitely get the counterclockwise direction. And remember, as I said before, here the sequence is started from 06. Sequence can be started at, as we have seen before, sequence can be started at 06, 03, 09, 03, anywhere. Okay, so in this case, sequence is started 06 at 06 value, and it means, and in order, instead of 06, they placed 666 to make the code more efficient, and the pattern will remain same. So this is the example. Hope you understand each and everything. Do practice. If you want to go to YouTube channel, you can you can see some more detail. But this lecture was aimed to interface the microcontroller with the stepper motor. So we have this material, but if you want to know something more about the construction of the stepper motor, there are a lot of YouTube channels available. You can go and see. Thank you very much for watching this video.